Number 7 is exactly the same as number 6, only the matrix is different. So we're going to use the same method as you see the formulas on the slide here. So again, this matrix game is not strictly determined because if you look at the row, the minimum value is -1. Second row, minimum value is -1. So -1s are circled. And then looking at the columns, we box the largest values. So 5 and 3 are boxed. So we don't have a common number that is circled and boxed at the same time, which means there's no saddle point. So it's non-strictly determined game. So when that happens, we can use these formulas to figure out the optimal strategies and the value of the game. So let's start with the value of the game, which is, according to the formula here, A times D minus B times C divided by D, and that's capital D, which is A plus D minus B plus C. So, and these are the entries A, B, C, D. So looking at this matrix, A is -1, B is 3, C is 5, and D is -1. So AD would be these two multiplied +1. BC would be 15. Subtract them, you get -14. So -14 divided by this capital D, which is A plus D minus B plus C. So that's -2 minus 8, which is -10. So we got -14 divided by -10 for V, which is, if you simplify, you get 7/5. So 7/5 is the fraction that represents the value of this game for V. So we found V. Now we're going to find the optimal values, strategies for each player. So we still need that capital D when figuring out the P star and Q star. So keep that in mind. D was -2, these two added, minus these two added 8, so that gives us -10. So capital D is -10. So then just looking at here, P star would be D minus C, so this is D and this is C. -1 minus 5 is -6, and you divide that by D, capital D, which is -10. -6 divided by -10 would give you 3/5. So that's the first entry of the P star. And then A minus B, which is -1 minus 3, -4. So -4 divided by -10 is 2/5. So P star would be 3/5 and 2/5. And then likewise Q star would be D minus B. So this is D, this is B. Those two subtracted gives you -4. Divided by -10 is +2/5. And then A minus C, according to the formula here, A minus C is -6 again. -6 divided by -1 is 3/5. So the Q star would be 2/5 and 3/5. So that's number 7. So number 8 is probably the easiest problem you can get. Find the smallest integer k such that adding k to each entry of the given matrix produces a matrix with all positive payoffs. So what should you add? The same number added to every single entry. That's going to turn all entries to positive. Meaning, so you're not trying to so you need to basically locate the smallest entry, which is -6, because that's smaller than -4 and -2 and 2. So what should you add to make it positive integer? So you're not trying to make it 0, you're trying to make it 1. So -6 plus 7 would actually give you 1. So that means k equals 7 should be added to each entry to make this matrix with all positive payoffs. Okay, so k equals 7 for number 8. Number 9, solve the matrix game using a geometric linear approach. So let me show you the geometric linear approach. So here, this is 10.3 slide deck, the geometric approach. So basically you set up the minimize, maximize formulas with these constraints. and then yeah, you get all of these, and then you solve each system. And once you solve each system and figure out the v, you just multiply the x and x1, y1, and z1, z2 with those v values, and that would give you the solution. But this is kind of the hard way, the geometric approach. It doesn't matter which approach you use. In fact, I would use just the this approach again that we use with the formulas, because that's a lot simpler. You don't have to solve any system. Solving those systems would take more time. So again, let's take a look at this. So here, looking at this matrix, A equals 2, B equals -4, C equals -6, and D equals -1. And these are gonna be all lowercase actually, because we have an uppercase D. And uppercase D equals, going back to this, A plus D minus B plus C. So A plus D minus B plus C. So that would be, let's figure that out. A plus D is 2. So 2 plus D is -1 minus B plus C is -4 plus -6, which is, this is just going to be 1 minus, and this is going to be -10, -10. Let's this way, -10, and that's going to be equals 1 plus 10, 11. So capital D is 11. Let's write that down here. And so P star is, so let's write that. P star this is P star, and this is Q star. And this is V. Okay, so let's figure out V. So A times D, that's 2 times -1, which is -2. And then minus B times C is -4 times -6, which is +24. So that minus comes from this. And that divided by, hold on, divided by capital D is 11, which would give me -26 divided by 11. So that's the value of V, -26 divided by 11. So now let's look at P star. P star is D minus C over capital D. So D minus C, that's -1 minus -6. So let me do that. -1 minus -6. So notice there's so -1 minus -6 turns +6. And then that divided by capital D, which is 11. So that's the first entry of P star. And the second entry is A minus B. So 2 minus, okay, so the first entry is D minus C. Did we do that right? D, yeah. And the second entry is A minus B. So 2 minus -4. So that's 2 minus -4 turns +4 divided by 11, capital D. So that's going to give us P star equals, this is going to be +5, so 5 over 11. And the second entry is 6 over 11. So that's P star. And likewise Q star is, I don't need these anymore. So Q star is D minus B, so -1 minus -4, so that makes -1 plus 4 divided by 11, because that's capital D. And then the second entry would be A minus C, so 2 minus -6, which makes 2 plus 6 divided by 11. So that would be, so Q star would be 3 over 11 and 8 over 11. Yep, so those are the answers for number 9. So number 10, explain why the value of a matrix game is positive if all of the payoffs are positive. So the payoffs are the entries of the matrix. Each entry is like a payoff. So if all of the entries are positive, that means when you circle and box those minimum maximum entries with the rows and columns, if there's a saddle point, in other words, if the game is strictly determined, so if the game is strictly determined, then the saddle points, so if, and all of the payoffs are positive, then the saddle point will be obviously positive. It can't be negative because all of the entries are positive. So it's not A. So if the matrix is strictly determined and all of the payoffs are positive, the saddle value will be, it has to be positive, and the saddle value is V, the value of the game. So that's also positive. So this is the case if the matrix game is strictly determined. All entries positive. If there exists a saddle point, meaning if the game is strictly determined, V has to be, the saddle point has to be positive. So what if the game is non-strictly determined? That's when we look at that capital D, A plus D minus B plus C, and then divide that by the entry, the AD minus BC. So when all of these entries are positive, A plus D minus B plus C, so we don't know for sure if this is going to be negative, but if this is positive, meaning A plus D is larger than B plus C, then A times D will be also larger than B times C. So both of these entries will be positive. So when you divide them to figure out V, you'll get positive. But in case A plus D is a smaller quantity than B plus C, which means the capital D will be negative, then A times D will also be smaller than B times C, which means this will also be negative. And when you divide them to get the value of V, dividing two negatives will still be positive. So therefore V will be positive. So the correct answer here is answer choice C. Alright, so that concludes this tutorial.